Alright, so this video is about how to add a voltage regulator to a generator that does not have one from the factory. I looked on YouTube and through the internet. I could not find any videos or any actually articles or anything on the internet on how to do this. So if you hang in there, I'll show you how to do this. It's kind of complicated, so you need to kind of be patient and yeah, allow me to explain things. So I'll go through the simple, just like no explanation of how to just make the connections and have it work, but it's a little bit more complicated than that, so I'll go into a little more explanation of things at the end of this video. But for now, this is what we're looking at. Let me turn the flashlight on. So this is what it looks like. You got 5 wires here, 2 wires over here, and these 2 wires go to what they call a set of brushes. These brushes transfer DC voltage into the center of the generator windings, the rotor windings. So what that does is, well, yeah, I won't explain it, but basically you have to take these wires, disconnect them from the brushes, and connect them to your new automatic voltage regulator that you bought. This is a heavier duty one. It's 5,000 watts, a 9,000 watt unit. It's adjustable, so it has this little thing here. It's a, adjustable resistor. So you can use that to dial it in somewhat, but that's not nearly enough to actually get this to run correctly. So I'll explain that in a minute. But basically these 2 wires need to connect to these blue wires here. I think sometimes there are 2 sets of yellow wires on some machines or some voltage regulators. So these wires connect to there. So I just plugged them in, they're connected. So these 2 wires, the red and white one, the red one will have, it's not always these colors, but they should be labeled. So you have a positive and a negative. The positive one has this label on it, so you know it's positive. That will go, in my case, to either one of these connections here that you pulled these wires off of. So you can plug them into either one of this, because you have what you call a bridge rectifier that sorts it out. So even if the positive is connected back here to the negative side of it or whatever, it doesn't really matter, because it's gonna figure it out and transfer the positive power to the positive brush here. And on the back, this backside brush is a negative brush. So, but I suggest in this case, on this on these Briggs Stratton generators, I think most of them are positive here, negative there. But so yeah, that's what these 2 wires do. And then the last 2 wires, this is where it gets tricky. And it's not just a quick plug and play. You can't just buy this and just plug it in and make it work, because we're missing 2 wires on this generator to make this work. So what you have to do is find the correct wires and splice into them and add wires to these to branch off of these 2 wires and go into your voltage regulator. This connection here, these 2 wires need to splice into here, but you have to have a resistor between here and here. So in order to figure out how much resistance you need, you can use a potentiometer, which is a variable resistor. In my case, I use this. I dialed it in, started the machine up, and then I adjusted that until I got 120 volts out of my outlets here. And then I disconnected the wires off of this, measured the resistance of what this was set to, and that gave me a value of 7,500 ohms. And so then I went on the internet and I bought a 7,500 watt or ohm resistor that was rated for 3 watts of heat dissipation and 1% tolerance. If you can find a 5 watt, it'd be, you know, even better. The wattage is just the amount of heat it can safely dissipate, you know, so the thing doesn't fail. But the resistance in it needs to be, you know, whatever number you come up with. In my case, it's 7,500 ohms of resistance. So this resistor needs to take the place of this potentiometer. So basically, you could just unplug these wires off of there and connect one end of the wire to one end of the resistor and the other to the other end. So you'd have it, you know, that it's going to be connected like that, but I strongly suggest you actually solder the resistor lead to the wire, and then use some heat shrink tubing. Probably cut the lead down a little bit more, and definitely you want to cut the wire length down. You don't need all this long wire. So you just need one resistor on one of these wires, and it doesn't matter which wire it is. And then the other end of the wires, like I said, they need to splice in into this plug here, like, you know, make the connection like this. In my case, I was just using these connectors and just jamming them in the back side of the plug for testing purposes like that. And then you know, I was, you know, dialing it in like this. But I'm gonna take all this long wiring here, and I'm gonna cut it all down and do this proper with the resistor, you know, connected in there. But I will start this up, and then you can see how it works. Alrighty, so you saw me fine-tuning the voltage regulator here itself with the new resistor connected. So it's a little bit warm. If I leave my fingers on there for too long, for like 5-10 seconds, it's going to be too much heat to, you know, touch without getting kind of burnt. So yeah, I would say 3 to 5 watts is good as far as the resistor goes. So the same thing can work. Like I said, I'll start it up with the variable resistor. So these potentiometers or variable resistors normally have 3 prongs on them. I accidentally broke this one off, but basically the wires need to be, one wire has to be connected to the center. The second wire needs to be connected to, you know, one of the other wires on either side of the center wire. It doesn't matter which side, really. So I'll connect that up, and then you can see as I turn the potentiometer, the voltage coming out of the outlets is going to be different. I mean, not different, but it'll vary. I can adjust it with this thing. Alright, so you can see me adjusting that. It doesn't take much of much movement to fluctuate the voltage coming out of the outlets, for sure. So anyway, that's how you use one of these, and then you can figure out how much resistance you need, what value of resistor you need to put into the in line there. So hopefully that helps. So to understand this a little better, how this all works is this generator basically has a center electromagnetic coil here. So this coil needs to be energized with and have electricity flowing through it, which creates a magnetic field. That magnetic field, as that center thing rotates, it creates electricity. So if these coils are not excited or energized, then it doesn't produce any power into the output coils, these main coils. So you won't get any AC voltage. But the voltage going into the center rotor coils here, the field coils, need to be DC. So that's these brushes here. So these have to be DC, and they have to be in the right order. So this is the voltage regulator inputs that power into the brushes, and then the brushes transfers the power to these coils back here. And as if the voltage in the outlets are too low, if you're getting too low of a voltage reading, AC voltage, then the voltage regulator says sees that, and then it inputs a higher DC voltage into the brushes here and into the coil, which increases the AC voltage coming out of the generator. So that's how this side of it works here. So these are the exciting, these are coming from the exciter coil. So this is AC voltage coming out of the generator, and that goes into the voltage regulator here. So because these are AC, because this is AC voltage, yeah, these wires can be swapped around. Like the blue can be where the red is, and the red can be where the blue is, and it's not going to be a problem. They do need to go to these blue wires there. Sometimes they're yellow wires, but they're the same color wires. And then on the other side you have the last two wires, which are these, and that's the reference voltage, and that's the AC, again AC voltage, but that's AC voltage from the output of the generator, the AC voltage going out to the outlets here. And so you're tapping off of there to allow the voltage regulator to be able to see what is being output here, and if the voltage is too low or too high, the regulator regulates that voltage and adjusts the voltage going into the coils there. Each generator is going to have a different setup and a situation with the adding a voltage regulator to it. So in order to figure it out, you do need to have like a potential meter or something, and dial it in, and then measure the resistance after you've got everything adjusted and you're getting 120 volts out of the outlet. Then measure the resistance, disconnect these wires, measure the ohms that this is set to, and then that'll give you the value that you need in resistance to buy the proper resistor to replace this. You don't really want to keep this in the system because this easily can go out of adjustment, and you don't want that to happen. You can fine-tune the adjustment with the voltage regulator adjuster screw there. So when you find a voltage regulator to add on to your generator, you want to make sure it has an adjustable voltage regulator with the little adjustable resistor pot or whatever you call it there. So hopefully this helps. And here's the diagrams for your reference. So you have the exciting wires from the secondary coil or excitation coil, and those were these wires that were originally connected to the brushes. That's these wires here. And then these wires are actually not really visible. They're kind of internal, right behind the brushes and the circuit board where the diodes are attached to. That's these right here. And so that's on my generator. And then you don't have any connection between the power coils or the stator coils or whatever, and the and this circuitry right here. But on the newer machine, or the bigger generators that output higher watt, you have a voltage regulator. So this is also Briggs Stratton wiring diagram. You also have a field coil and an excitation coil. Yeah, these wires go into the voltage regulator instead of going into a bridge rectifier or diode. And but then you have two extra wires. So these extra wires, the red one is your neutral, and then the blue one is your hot wire, AC wire. And that's these two wires here. So there's your neutral, and then the hot AC wire. And then those are the ones that you're gonna tap into and branch off of. And then one of those wires is gonna have the resistor in line with it. The other wire is just gonna go straight into the plug here. So anyway, I don't know what else I can explain, or how more thorough of an explanation I can make of this. Any questions you have, just leave them in the comments. And I just just wanted to make this because nobody else has made a video on this and explained it. So hopefully this helps. Alright, so I got my resistor wired up here. Got the heat shrink tubing, got that end already crimped on. And then we'll just solder these joints here. Alright, so I got that all soldered up. Alright, so I just depinned this terminal out of the factory connector here. This wire with the resistor in it. Just wrapping around the end of the terminal there. And I'll also crimp it, and then yeah, I'll get some solder, and I'll solder this copper wire to the terminal, and then I'll put it back into the connector, and then I'll do the other one. The white one's gonna go to the red wire right there, same way. All right, this is the final result of it. So pull the cover off here. I got the voltage regulator zip tied to the side here. Just drilled a couple holes through this case, zip tied it there. And then the wires go through here. I just kind of notched the cover so the wires could slip through the side. And then yeah, and then I got these wires. This is a wire with the resistor on it. I put it green because sometimes the voltage regulators that you buy, it's a white green wire instead of a white gray wire. So and I couldn't find a gray wire that was thick enough, so I just used the green, and that has the resistor in it, and that goes down here, and it's soldered into these connectors right here, terminals. So it's spliced out. You know, the white one's connected to this red, and then the green one's connected to the blue. All right, I'll get this thing started up, and we'll test it. So yeah, as you can see, it works pretty good. If the RPMs get too low, you know, it fluctuates, drops maybe a volt or two. But compared to not having the voltage regulator on there, it's a huge night and day difference on how well it regulates the voltage. So yeah, anyway, I hope this helps. If you have any questions, just leave them in the comments, and I'll do my best to answer them. All right, take care. Bye.